video we are going to derive the relationship between drift velocity and relaxation time. So if you want to know more about drift velocity, you can check my previous video. Links are given in the description box. So before we derive the relation, we should know some formulas, and these formulas are V is equal to U plus AT, that's the first equation of motion. F is equal to ma, formula for force. E is equal to F by Q, this is the formula for electric field, which is force per unit charge. So let's derive the relation. So in order to derive the relation, I'll consider n number of free electrons inside a conductor and moving with velocity u1, u2 and u1, meaning the electron number 1 is moving with velocity u1 and electron number 2 is moving with velocity u2. Similarly, electron number n is moving with the velocity u1, and as they are moving randomly, so there will be no average velocity. So average velocity will be 0. If you can write the average velocity, so that is all the velocities addition divided by number of electrons will be 0. So this is equation number 1. So but when you apply the electric field, the electron will start moving in one direction, that is the opposite direction of electric field. They will start slowly moving in this direction, so they will drift in one direction. So the force on each electron will be given by the equation F is equal to minus E. So as we all know, electric field is force by charge, so force will be electric field into charge. So for electron, the charge is minus E, so that's why I got this relation. So now in this equation, minus sign is indicating that electric field and force, they are in opposite direction. So when you apply force on electron, they will start accelerating. As we all know, force is equal to mass into acceleration. So their acceleration will be force by mass. So if you put the value of force from previous equation, that is minus EE, your acceleration will be minus EE by m, and the acceleration of electron will be there during only two collisions, because after each collision the electron will stop for some time and its acceleration will become 0. So, and in this equation, m is the mass of electron, and due to this force, the velocity of electron will change. So there will be increase in velocity. As we all know, when you apply the force on slow moving object, it will speed up. So the final velocity of first electron will be given by this formula, V is equal to U plus AT. Final velocity is equal to initial velocity plus acceleration into time. So V1 is equal to U1 plus acceleration, and time I am taking to be tau 1. So tau 1 is a time between two successive collisions. As I have said, the acceleration will be there only between two successive collisions. So after each collision, the acceleration will become 0. So similarly, for second electron, I can write the same equation. For nth electron, I can write the same. So if you take the average of all the velocities, final velocities, so V will be V1 plus V2 plus dot Vn by n. So now if you put the values of V1, V2 from here, so equation will look like this. So now I'll keep all initial velocity one side and all acceleration and time one side, so your equation will look like this. So I'll separate the equation now. So it's like this. So now this term is a average initial velocity, which is 0, as we already know. So using equation 1 as we have seen, so you can see the equation out here. So this will be 0, so I'm left with this. Now again I'll put average of this to be tau. So I'll put if tau 1, tau 2 dot tau n by n is the tau, that is the average time between two successive collisions. So then my equation will look like this. So instead of this, I have put tau. So V is equal to acceleration time tau. So please give the vector for acceleration. So now as V dash is the average velocity, and average velocity of electron is also known as drift velocity, so I can write V as Vd. So my drift velocity will be a tau. Now if I put the value of a acceleration, that is minus e by m tau, so that I'll get the relation between drift velocity and relaxation time. So this is the final expression, and this minus sign is indicating that the direction between drift velocity and electric field are opposite. Suppose electric field is towards the left, drift velocity will be towards the right. So now one question will come out here is, so drift velocity of electron inside the conductor is very small. See, it is of order of 1 millimeter per second. So meaning that to cross one scale, it will take 5 minutes. So the question, but when you switch on the lights, switch on the light, it will not take any time. So it will just glow instantaneously. So why is this happening? If the electrons are moving very slowly, it should take some time. So but out here it's not taking. So the answer is, the electron from the switch will not go to the bulb. So the electrons near to the bulb will start flowing. When you switch on the circuit, the electric field will be set up in the circuit with the speed of light, and with that all the electrons will start flowing. So it will not take any time. By the time it is switched on, all the electrons start flowing. So it is same as when you open the tap, it will not take time. No, the water will come instantaneously. So water near to the tap comes first, and it is not coming from the tank directly. So it will come. So same thing happens out here. So as you can see, pause and you can copy this why it's happening. Thank you. Don't forget to like and subscribe.